Okay, so number one right here. The question is that not asking what is slope and y-intercept, it's asking what it means. So just like in the last assignment, I was asking what does it mean in the context of the question. So in the context of this question, if this is the value of car and this is the age of car, what do you think the slope represents here? What does the slope represent? Okay, remember slope, rate of change. In terms of the context of the question, Megan? Perfect, right. So your rate of change in this case is the depreciation rate. Okay, what does the 19,000 represent right here? Your y-intercept. Yep, Casey? Initial value of the car, right? The starting value of the car. So when it was new, how much it was worth. Good. Number two right here. Why can't I do first difference? Ethan?
Because the data points are in order.
Right, the data points are not in order. Even if I put it in order, is it going to help? Even if I rearrange these and put it in the right order, will it still help though? Because it's like 2, 3, 6, 8, and then 11. So it still doesn't help. But so what's the easiest way to calculate the rate of change in this linear relation then? Aiden?
Compare that to y, divided.
What do you mean by divided? So how many points do I need to find the rate of change?
2.
2, right? Yeah. So this table is actually to trick you guys. Okay. So just because you're given a table, you don't have to go to first difference. You don't have to rearrange it. You can. These are just points, and to calculate the slope or the rate of change, you only need 2 points. So choose any of these 2 points here, and just do the slope formula, and you'll get your rate of change. Okay. So that was a little tricky there. Number 5 with the nickels and dime. Is this a continuous or discrete relation? All right. Shrenik, is this continuous or discrete? Why?
Because you can't have fractional dimes.
Right. You can't have half a dime. That's right. So half a dime is not a nickel. Okay. If you try to pay for something with like half a dime after you cut it, they're not gonna consider it a nickel. Right? These ones right here is just like filling out the blank, doing actually the first difference. This number 8. Given this equation, a equals 4 pi square. Is this linear or nonlinear? Number 8. Aaron, would you say this is linear or nonlinear?
Non-linear.
Yeah, that's what he meant. Okay, but why? But why? Okay, so this equation, just this equation, looking at this equation.
It's non-linear because that's the exponent.
Exactly. Okay, so the exponent tells you it's nonlinear. But what if, Aiden, what if my equation was a equals 4 square pi? Is that linear or nonlinear? Because?
4 square.
Yeah, 4 square pi.
Linear.
Why?
Because 4 square is a constant. Wait.
Right, it's still a number.
Yeah,
right. So
technically, that's also linear because
you have a variable. Yes, r change. We'll say r is the unknown. So when you have the exponent, it's not just exponent. The exponent has to be on the variable. Right? Da, 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 da. Okay, this one right here, number 12. Number 12. The wording of this question is bad. Okay, why is it bad? Number 12. Okay, why is the wording in number 12 bad?
only one must know.
Okay, Casey?
It says $50 per day and $100 per day.
Right, so there's a lot of per day, per lawn, and everything. So there's more than one per right here. In grade 10, yes, then you'll have like multiple variables. But in grade 9, we want to try to just keep it with 2 variables. So if I were to reword this question, I will say how many lawns must he mow to earn $100 for the one day. So when I say for the one day, then you don't have the $15 per day variable. So instead, it would just be y equals 5x plus 15 rather than y equals 5x plus 15z, for example, or 15d. You don't want to introduce a third variable. Okay? And then for the 100, where am I substituting the 100? For the x or for the y? For the y, right? So when I substitute it for the y and solve for x, I get x equals 17. 17 what? $17? Lawns, right? All right. So don't forget your x represents the number of lawns. So 17 lawns. Okay. Oh. Okay. Number 19, the wording. All right. Shrenik. Collinear. What does collinear mean?
All on the same line.
All 3 points are on the same line. So how do I prove that? Right. Okay. If they're all on the same line, it means that they all have the same slope between the points. So how many times do I have to check the slope? How many times do I have to do the slope formula? How many times do I have to check the slope formula here? Yep. 3 times. Okay. Do I have to do 3 times? Do I have to do x to y, x to z, and y to z? No, I just have to do it 2 times. If the slope between this and the slope between this and this is the same, it will imply that this and this is the same. All right, so I don't have to do it 3 times. I can just do it twice because it will imply that the third point is also the same slope. Okay. Number 22. Okay, so number 22, write the equation of a line perpendicular to the x-axis and passes through this point. So during the lesson, when we did this, what's the easiest way, again, to do these questions perpendicular to the x-axis? Should I solve it algebraically? Easiest way.
Simple graph?
Simple graph. Good, thank you. Someone was paying attention. Okay, so it goes through the point -5, -9. It's perpendicular to the x-axis, which means I'm looking at a vertical line. So a vertical line is x equal, as we said earlier. Okay, so as simple as that, we come up with the equation right away. Especially with vertical line, you actually cannot solve it algebraically, because you have the denominator of 0, so it actually won't work. Okay, write the equation of a line that is perpendicular to this and passes through that. Okay, so I would say this is as hard as it will get on your test tomorrow. Okay, so number 23. Rearrange this equation first so that you get the this. Okay, so looking at this, my slope is 4. I want the perpendicular slope. So if my slope is 4, what's my perpendicular slope? Richard? You know, if my slope is 4, what's my perpendicular slope? Remember negative reciprocal. Right? Negative a quarter, right? But don't forget the negative as well, because it's negative reciprocal. Good. But we're not done the question. Nowhere near done the question, Aaron. All right? I'm looking for the equation. So if I have this point and I have this slope, what am I supposed to do?
Put it in the equation y equals x plus 2.
Right, and solve for? Yeah, what are we solving for? Why are we doing that? We want to solve for? Okay, we have x, y, we have m, so we're solving for b, right? Okay, when you multiply this, you'll get 3, so that means your b is just 1. I have m, I have b, So my equation is just y equals negative a half x plus 1. Okay. Okay, let's move on. These, the motion graphs. Okay, I want to go over this motion graph with you guys because last week you guys did it with a supply, so I want to make sure you guys all understand it. So I know there's questions here, but I want to go over like this chart with you guys. Okay, so between A to B, so I'm only looking at this segment right here between A and B. What's the distance traveled? Richard? 30, good. Okay, how long did it take? 30 kilometers, right? Don't forget the units. How long did it take? 1 hour. Okay. Here's the most important part. Simon, what's the direction? Yes, direction. From A to B. Forward? No, no. Not to the right, not forward, not up, not positive. Direction. Away. Okay. Remember, motion graphs is never up or down or left, right. It's away or towards. Away from what? Uh, in the context of the question? Away from the parking lot. Okay. So a lot of times it's either like away from home, away from school, away from parking lot. Okay. And what's the speed then? How do I calculate speed? Distance divided by time. So in this case, Aaron, what's my speed? 30 kilometers per hour. Good job. Okay. Good with the unit. Remember, your speed is rate of change. So it's 2 units. Okay. Connor, what happened between B and C? A horizontal line and a motion graph means? What do you mean stays the same? It didn't change. So what were you doing? Yeah, you're standing still, you stop. Right. So in terms of distance, you still have, so in terms of distance wise, it's 0 distance. All right. But what about time? You're standing still, but does time keep going? Yes, time doesn't freeze. So you still have the time, 15 minutes or 0.25 hours. In terms of direction, Aiden, in terms of direction in a motion graph?
Towards.
Right? B to C is a horizontal line. Right, so you stop. So in terms of direction for a horizontal line, there's no direction. You just simply stop. And then speed, 0 kilometers per hour.
Direction specification if you're not moving, can you say
Sure. Okay. As long as I can tell that you understand the question, then it's okay. Let's see. Who should I ask? So Joanna, between E to F, what's the direction here then? Towards the parking lot. Good job. Okay. It's not enough to just say away or towards, but also the point. Okay. So at point H, Connor, what happened at point H? Where are you? Where are you at point H?
You're back to your phone.
Which is?
Parking.
The parking lot, right? All right. So you're going away from the parking lot and then you're coming back to the parking lot. That's what's happening. Remember, you're not going up a hill on that parking lot. All right. There's no mountain, no hills on it, and you're not rolling back to the parking lot here. Okay. Last one right here, number 29. Ryan, you have a window washing business. Yay. Okay. So, are you making money or losing money? Let's see. You're charging people $5 per window and you're $10 minimum charge. So your graph looks something like this. Okay. What if you decide to increase your minimum charge? What do you change? Y-intercept. So it becomes something like this. How's the slope in these two lines? How's Aiden? I'm talking to Ryan. How's the slope for these two lines? Slope's the same. That's why you can see it's parallel. Okay. What if now you want to keep that $10, but you are charging more for each window? More steep. Excellent. Okay, so you're charging $30 now. Talk about the rate increase. Okay, so much more steeper. Um, Now, what if you decide to change both? Increase the minimum charge, but lower the cost per window. You're lowering the price. Yeah, less steep, right? So more flat or less steep, and so higher y-intercept, less steep slope. Okay, and then finally, this one is a tricky one. All right, Aiden, why don't you try this one? What if Ryan is gonna charge at maximum cost? How would your equation or graph look like?
Maximum cost.
Yeah. So if there's a maximum now, how do I denote a maximum in my equation?
Um,
Inequality. Good. Okay. So let's say I have something like this. The maximum charge is 400. How would my graph look like then if there's a maximum cost?
line of shade.
Well, all lines are straight. Okay, so at the first part, it will look something like this. And then horizontal line. Good. Okay, so eventually your line will look something like this. Okay, so is this a linear relation? No. Okay, because it's obviously it's the first part, yes. Second part, yes, but together, no. Okay. Okay. So those are the 29 questions. Any ones that I skipped, remember there are answers on that very back page. Do try everything. But I went over like the most important ones that I think you should pay attention to. Okay. So for tonight, make sure you study everything. Chapter 5, Chapter 6, Chapter 7 package, and this review package. Right?